Dear students, we are entering into the next chapter, that is physical quantities and its measurement. So we know that every substance has some mass and volume. So we will be in this chapter, in this first part, we will be dealing with what is density, how is it denoted, and why substance become denser or rarer, and what is the unit of density. So read the book along with me. There's no big thing in it, but you read carefully with me. Okay, we have read in the previous classes that every particle has some mass and some volume. So every particle has some mass and volume. So first point is same masses of different substance have different volume. So if, for example, if you take 1 kilogram of iron and 1 kilogram of cotton, you tell me which one will occupy more space. So obviously for cotton it needs more space. 1 kilogram cotton may be more. When we see in space, it needs more space to occupy, and the iron bar will be very small but thicker. So from this you can understand that same mass of different substance have different volume. So simple reason for this is that iron is denser and cotton is rarer, having lot of inner particle space. Iron molecules are thickly packed and they are so close, and they don't need much space. But in cotton there's lot of interparticle space. So it occupies more space. And the second thing is that same volume of different substance have different masses. Same mass of different substance have different volume. Same volume of different substance have different masses. So nothing is the same. So in both the cases it is different. If mass is same, volume will be different. If volume is same, mass also can be different. So mass of given volume of iron is much more than the mass of same volume of plastic. Simple reason for this is that iron is denser than plastic. Thus, to take care of above mentioned variations, we use the concept of density. So this thickness or denser and rarer. So in order to denote the thickness of this thing, of the substances, we use the term density. So what is density? The density of a substance is defined as the mass per unit volume of the substance. So this you have to underline, you have to learn properly. The density of a substance is defined as mass per unit volume of the substance. And how it is denoted? Density of the substance is denoted by D. Okay, what is density? Density is mass of the substance per volume of the substance. So it is denoted by D. And here D equals to mass of the substance denoted by M and volume of the substance denoted by V. So D equals to M by V. Now we will be dealing with how to find out the unit of density. So we have two quantities here. So we have to put the units of these two quantities. So unit of density, mass. What is the unit of mass? Mass may be kilogram, gram, or those. So unit of mass is kilogram and volume is meter or centimeter cube. Volume is cube. Volume is measured in cube, no? So kilogram, meter, cube. Kilogram, volume is meter cube. Since it is down, what we are doing, we are bringing it up by putting a negative sign on it. So kilogram, meter raised to minus 3. So kilogram, it is in the down part, no, denominator. So what happens when it comes up? It will be negative sign. So kilogram, meter raised to minus 3. If it was here, here in the same line, no, so we are not changing the sign of kilogram. Kilogram is as it is, and then meter is down. So when meter comes up, what we will be doing, we will be just putting a negative sign on it. Okay, kilogram meter raised to -3. So unit of density is mass divided by volume. D equals to m mass, V volume, and then we put the unit of mass and volume here. Mass is in kilogram and volume in meter cube, and so the unit of density is kilogram divided by meter cube, or kilogram meter raised to -3. If mass is in gram, then the volume also will be in centimeter. If mass is in gram, it will be, here meter will change into centimeter. Then the unit of density is gram centimeter raised to -3, or gram per cubic centimeter. So 1 kilogram meter raised to -3 equals to 1 kilogram divided by 1 meter cube. So 1 kilogram is 1000 gram and 1 meter is 100 centimeter. Okay, 1 kilogram is 1000 gram, 1 meter is 100 centimeter, and the cube. So 1 divided by 1000. When we cut, we will get, no. So gram centimeter raised to -3. So 1 kilogram meter raised to -3 is equals to 10 raised to the power 1, 2, 3 -3 gram centimeter raised to -3. So 1 gram centimeter cube is equals to, so gram 100, no, this 1, 2, and here 2 more we have to add, 1000 kilogram meter raised to -3. So the density of the substance does not depend upon the size or shape of the substance. Remember, the density of the substance does not depend on the shape or size of the substance. So the density of a substance decreases with the increase in temperature. As temperature increases, what happens? The substance starts melting and the density decreases, and increase with the decrease in temperature. As temperature increases, the interparticle bond or attraction becomes more and the substance becomes more thicker. But in case of water, there is a difference. That is anomalous behavior of water we will be seeing later. Water is an exception to it. Density of water increases from 0 degrees Celsius to 4 degrees Celsius. As temperature increases from 0 to 4 degrees Celsius, what happens? The density of water increases and then decreases above 4. After 4 degrees Celsius, the density decreases. So density of water at 4 degrees Celsius is 1000 kilogram raised to -cube.